Hello and welcome to Winslow Academy. In this lecture we'll be looking at how to make a network probe in Kali Linux using the Python programming language. We'll be making a little script that enables us to detect the different networks that the devices within our range is asking for. So what you're seeing here is our script currently telling me that there are some devices within the range of my wireless network card that is asking for the following networks. So if you want to build the script yourself, then please follow along. So we are now in the Kali Linux in our VirtualBox. We have VirtualBox running right here. So I have it running besides my main operation system, which is Windows. If you haven't installed Kali Linux in a VirtualBox before, then see the video on the right corner up here and just follow that video and you will be able to have Kali Linux installed like I have right here. So besides the Kali Linux, we are going to need to have a wireless network card. If you already have that in your computer or your laptop, then it's fine. It just have to have the possibility of being set into monitor mode. If you don't, then I'm using this wireless card right here. I can highly recommend it. It's not a sponsored link or picture, but you can see the link to what I'm using in the description. So the first thing that we're going to do is to create a file. And I will just be copying this little script because it's not that much, and then we will be saving it as, I will call it sniffer.py, and in the desktop right here, and then I will just zoom it up so we can see it with a bit more colors. So what we have right here is that we have from scrapy.alt.import and then star for all. So we're using this Scrapy library framework right here. You can read about it if you want. The link is also in the description. Then we have our variable interface, and then that has been set to the wireless internet interface in this VirtualBox that we are going to monitor from. So we are calling this WLAN 0. You can rename it on your own, or maybe yours have another name, but I will show you in a bit how you can get the name of this and how you set it up into monitor mode. Then we have the probe request, which is also a variable, which is an empty array because we have not any values yet. Then we have our main method right here, defined by the def in Python, and then we have its own container included right here, and then we say if it has a layer of this .probe request, meaning that this is right out of the box from this Scrapy, and that define the actual packages that we are looking for, the ones that will give us what we're searching for, namely the request for the network packages. And then we say net name, and that should be equal to, and then we get the layer of this defined package right here, and then .info. And if that name is not in our array right here, then we are going to add it, and then we will print the statement. So we are only going to see the same network names once, because once they have been added, it will be skipping this part right here and just continued looking for the next one. And then in the end we are calling the sniff method from Scrapy right here, and then we say it is to be an interface, and then the method that we will be using to define what we are looking for will be the method we defined right here. So this is the little script that we will be needing. We can close this now, and now it's time to make sure that our connection is set up in monitor mode. So we'll enter the terminal and say if config, and as you see right here, we have our wireless setup. So this is our WLAN 0. So first we say if config WLAN 0 down, meaning that we are closing for this one. And as you see right here, it's WLAN 0. If you have another name, then you need to replace this right here. And then we say down, and if you just run the if config again, we see that this has now been shut down. Now we need to re-enable it, so we'll say W this time. Remember that this is not an F anymore, but a W. And then we will say WLAN 0 for the name again, and then the mode to be monitor. And then we simply just start it up again. So if we type config again, we now see that we have our WLAN 0 set up and it is now in monitor mode. So now we are able to run the script and see the result. So we will be navigating to our desktop to open this file. A way to do so in Linux is typing ls to see where you are. As you see, we are not on the desktop yet, so we'll type change directory and then desktop. And from here we can type Python in order to execute a Python file, and then we will simply just name the file, so sniffer.py. And then we will wait, and as soon as it gets packages incoming or see that there are some packages asking for a network, meaning that the devices are asking, we will get them. So as you see right here, there are some device near my location that is asking for this network right here. There was another one, and then the script will just keep running and basically return whatever the devices in range are asking for. So by that you can get a intuition of where the different devices has been. So if you suddenly see that there are some Starbucks internet or something that you can use to identify exactly where people have been, then this starts to be really funny. I'm just sitting in my apartment, so this means that my neighbor's packages is getting showed up as well. So I have not seen any of these yet, so this must be one of my neighbors and their device is asking for previous networks that they have been on. So this was all for this little video. Remember to like and subscribe, and I will see you next time here on Winslow Academy.
Hello and welcome to Winslow Academy. So in this video we're going to look at how we can make a simple file encryptor in Python. So we have the code right here, which we walk through together, and then we simply have a text here called plaintext.text, where I have written a little message, which is the one that we're going to encrypt and also decrypt. So basically what we'll be using is the Fernet library, and you can go visit them online and read more about it. They have a lot of complex methods that you can use for encryption for a lot of different purposes, but what we're going to use it for today is just a simple file encryption. So nothing further complex. But if we go and look at the methods that we will be needing in this project, we will first have to generate a key. So that is the key that we will be using to encrypt our file and also decrypt it, of course. And of course that also means if we lose this particular key, we can of course not decrypt the file, because we need it in order to decrypt and encrypt the file. So the first method is simply just return a generated key. And what we'll be doing with this is that we'll be saving this key in our key file, which is going to be called encryptedkey.key. And this file will be created automatically when we run the script, which we'll do in a few minutes. Next off, we need to save the file, as I just mentioned. That is what we're doing here. So that will create a file and save it. And then we of course also need to load the key that we have saved when we need to, for example, either encrypt something new or to decrypt something that we have already encrypted. And again, this is just a very simple method. You see 2 lines here. We simply just open the particular key file, which is our encrypted key.key. Then we read from the file and just return the value that is in the file. So nothing further complex here either. The next method is the one where we're actually going to encrypt a given file. So that will be the one where we encrypt from our plain text. Here we will give it an input file, an output file, and a key, of course. And if we look at these 3 parameters, we will go down here and see the message. So the encrypt file will take an input file. The input file is the plaintext.text. That is the only file you need to have created as default when you run the script. And it's in here that you will have your plain text. So here we have Winslow Academy Python project. That is going to be the first input, the input file. Then we have the encrypted file. That is of course the file that will be storing our encrypted message. And then we need the key, which is the key that we just saw will be saved in the encryption key.key file. So we will take this input file, we will open it, so that is the plain text, read the message, then we will take the content and use this in order for us to encrypt it. So again, we'll use this Fernet library, where we'll just use their encryption method. Again, you can either dive into it directly from the library, or you can go visit them online as you saw before and read about how this actually works. But for now, we will just go along and know that we will just take the data from our input file and encrypt this. Next, we need to save this somewhere. So here we will be opening our output file, which is the encrypted file.txt, and then we will just write to that file. So very simple method here. The complex stuff here is actually where we are encrypting the data, but that is being handled by the library, which is pretty nice. Next off, we of course also need to be able to decrypt the file, because if we have encrypted something, we can't read it because it will no longer be in plain text. So in the decrypt file, we'll do similar stuff as we do in the encrypt file, but the change here is of course that we'll be decrypting. So again, we'll be needing an input file, an output file, and a key. So the input file here will now no longer be the plain text, but actually our encrypted file, because that is the file that we want to decrypt. So we will open this file, read the data, save it in this variable encrypted data. Then again, we'll use the Fernet library, and now we'll use the decrypt method to decrypt the encrypted message. And of course, we'll do this with the same key that we used to encrypt it. Next off, we will open our output file. So this is our decrypted file.txt, where we'll simply just write the now decrypted content to this file, so we have it in a separate file compared to our plain text. And that's basically what this all the methods that this little project needs, and then we are ready to run it. So before I run it, we'll just quickly look at the order in which this will happen. So first off, we'll generate a key, and this key we will save in our key file, which we have named encrypted key.key. That will be saved here using the method we have already talked about. Next off, we need to define our input file, that is the plaintext.txt. That is already created here. You need to have this file created before you can run the project, but the rest of these files will be created automatically as you run this particular script. Then we have to define our encrypted file, because we need the name of it, and the decrypted file as well. The last thing that we'll do is to run the encrypt method, which takes these 3 parameters. Then we'll just have a little print statement just to see in the console what is actually happening. And second off, we'll run the decrypt file, which again also takes 3 different parameters, but of course the input values will be different, because here we'll decrypt from the encrypted file instead of the plain text. And again, we'll just do a simple print. Let's try run this. And as you see, we have just created a few files here. So 3 files were created as we ran this. So we have the decrypted file.txt, encrypted file.txt, and encryption key.key. And then we have in the console 2 lines, which is the one we saw right here, where it just says that plain text.text encrypted to encrypted file, and the encrypted file is decrypted to the decrypted file. So if we look at the key, it's simply just a one-liner saving the key that was generated, which has now been used to encrypt and decrypt the file. If we look at the decrypted file, we'll see if we look at the encrypted file, we'll see that we can no longer read this because it's not in plain text anymore. And that is of course because we have encrypted this. So this message will not be readable for anyone if we send this, for example, online over a mail, and some malicious person or a third party get access to it. They will not be able to read this. But if they use our encryption key to decrypt it, they will get the decrypted file, which states Winslow Academy Python project, and that is the same text as we saw in our plain text right here. So this is a simple and an easy way for you to make a file encryptor. Of course, you can extend upon this by instead of having it generate all this by automatically, you can have it take input values such that you can on the fly run this and tell it what to do instead of just having it predefined right here. And of course, you can also have it using different keys such that it uses a public and a private key instead of the same semantic key when it do the encryption. Because the issue with this is of course that in order for anybody to decrypt your message, they will need the key, so you will need to find a way to transfer this key to them if it's not a message that you will only decrypt yourself. So this was all for today. See you next time on Venslov Academy. Hello and welcome to Venslov Academy. So in this video we are going to look at how we using the Python program language can make a simple password generator. So basically, in order for us to do this, a very few lines of code is actually needed. Let's take a look at it together. So we have one method here, which is our main method for generating password. Here we define the length of the method, and then we simply just take a different set of string characters. So we have the ASCII letters, we have digits, and we have punctuations. And then we combine all those, and then we say that our password here we will just take a random choice of the characters here in the range of the length that we have specified, and then we'll simply just return the password. And that is basically all we need for this simple method here. We then, when we run the script, we'll do so in a few seconds. We will simply ask the user for input. So we'll say enter the desired length of the password. So asking the user length of password you like based on the usage and the use case for the password. Then we'll have a simple check saying that if the length that the user provided is less than 1, we'll say that hey, the password must be at least 1 character. You can change this to, for example, 6, so we can make a simple check here saying if it's less than 6, then it has to be at least 6 characters long. Again, this can be specified as you deem necessary. And then we say else, so meaning that it is above or it is 6 characters or above. We will call this generate method here and store the value in this variable generate password, and simply then just print the password. So let's try this. So if we run this here, it will say enter the desired length of password. Here we can say 30 characters, and then it will simply just generate a password for us that is in total 30 length, a length of 30 long, and that include special characters, digits, numbers, etc. So that's a easy way for you to play around with a password generator. You can then extend or modify upon this. You could probably create a way for this to be stored in a file. We have a video here on the channel for how to encrypt file, and then you can actually start to make your own little password manager that can both generate passwords, it can encrypt the host file or the main file where the password is stored, and then you can have a password manager that is not connected to any central service, but is controlled by you as the owner of the encryption key. So this was all for this little video. Remember to like and subscribe, and then I'll see you next time here on Venslov Academy.
Hello and welcome to Venslov Academy. So in this video we're going to look at how you can make a Python encryption script that will encrypt a given message for you, and also decrypt it such that we are capable of seeing it both being encrypted and decrypted. So our little script here consists of 3 methods. We have our generate key method, which will generate a random key that we'll use for the encryption and afterwards for the decryption. So here we are making use of semantic encryption. Then we have encrypt message, which takes 2 parameters. It takes a key and a message. Based on that, it will take the library fernet, which also will use to generate the key. It will make a cipher suite that we will store in a variable, and we'll then use that to encrypt our message. And following that, we'll return the encrypted message such that we can print it and see it in the console. The last method is the decrypt message. That is of course needed to decrypt our message again such that it's readable. Here again it has 2 parameters. It takes the key, similar to the encrypt message, so this has to be the same key, hence we are using semantic encryption. And then it takes the encrypted message because we need that in order to decrypt it, of course. So if we run the script, we see here that first we generate the key, then we have a little input call here where we will ask for a message, so we can type in whatever message we would like to encrypt. When we have received that, we'll call our encrypt message, which will then encrypt the message, print it out for us such that we can see it. Afterwards, we call the decrypt message, which will of course decrypt the message
And again, we'll display this to ensure that we have actually successfully decrypted the same message. So let's try run this. So now we'll type the message. So we'll just say, for example, hello world. So this is the plain text message we would like to encrypt. We enter this, then we see that we have an encrypted message, which is this string right here. And then we decrypted the message again, meaning that we got back to hello world again. But we can also print out the key in case that, let's say, we want to transfer this message to another person, and we would like them to decrypt the message when they have received it. So they would need the key to do so. So we can just write print, and then we will just print the key variable where we are storing the actual key. So let's try to run this again. And this time we'll write hello world without a W. So as we see here, when we entered the message, instead of the encrypted message immediately, we actually got the key. So we can use this along with the encrypted message to decrypt it back again to hello world in case we need to transfer this. So this is a way that you can create a simple encryption script. You can then modify this as needed. It could be, for example, in a messaging app, similar to WhatsApp, where you want to encrypt messages coming in and you also want to decrypt messages coming out. But you can also adjust this to use asymmetric encryption, meaning that you're using public-private key, so a key pair to encrypt and decrypt, which is a more secure way because then you don't have to transfer the actual key along with the message, because if this key falls into the wrong hands, everybody with that particular key can of course decrypt all the messages. So in order for this to be a secure way of communication, the key here has to be kept totally safe, and you will of course wish that if you transfer it to people along with the message. So this was a quick way to create an encryption script. Remember to like and subscribe, and then I will see you next time here on Winslow Academy.
Hello and welcome to Winslow Academy. So in this video we're going to look at how we can make a file integrity checker using Python. So to illustrate what this actually is, we'll head over to this web page. So what we want to achieve with the script is to check that the files that we have downloaded or that we have previously downloaded has not been corrupted or interrupted with. So somebody has like changed something in it since we downloaded it. And if you go to most download pages today, you will be able to see that they have added a sum value. So if we click this, we can actually see the SHA-256 sum SHA value, which is this number right here. And what that number tells us is that for this particular file, the owner of this page has checked this use this algorithm to scan the file, meaning that when we download this file, we should be able to run the same algorithm on the file and get the exact same value. If we don't get the exact same value, we know that the file is not identical to the file that they have uploaded, meaning that something can have happened during the download phase while it came from their server to our computer. It could be a malicious user that has changed the file at route. That is of course unlikely, but it can happen. But it could also be that somebody sent us a file saying that, hey, this is the original file, you just need to install this instead of download it yourself. Then you can also quickly check whether this person is actually having the original file. You can check this also using the terminal in both Mac and Windows, but here we'll just look at how we can make our own using Python. So what we need is two imports. We need to import OS, the operation system library, and then the hash lib, because we are using the hash algorithm SHA-256. So this script, when we run it, it will prompt us with a prompt where it specifies us to give it a path where it has to scan. So this script will actually scan every file in the path that we provided. I will show you an example in a minute where we can see how this works. Then it will call the check integrity method that takes in this path right here. First, it will then check whether this path that we have provided actually exists. If not, it will cast an error saying that this does not exist. We can try to see how this works. So right now I'll just input no value at all, and it will cast a directory nothing, does not exist. But if we enter something, a folder, a directory that exists, then it will go through this loop where it will walk through each of the file names or each of the files in the folder. Then it will call the calculate SHA 256 method, which is our top method right here. And what that basically does is that it first specifies what algorithm to use. Remember that if you have a SHA that is calculated using another algorithm, you need to change that yourself. However, most people today use this one, but there is also a SHA 128 algorithm. But here we have the right algorithm for the file that we are going to check. Then it opens the file using just the standard Python open file method. Then it will read a chunk of the file and then it will do a break if there is no data. So meaning that it could not find the right data. But if it could find the data, it will use our SHA algorithm on that data, and then it will return the hexadecimal, so the output, which is the sum value we saw before. So let's try run this to see whether we have the right file of the Kali Linux operating system. So I've made a little folder here. I call it test SHA, and here I have put in the Kali Linux zip that I downloaded from kali.org. So this the value that our script here calculated for this should be the same value as we saw on the web page. So let's see if that is correct. So I will just copy paste here. Then first it will just scan the standard DS store, that's just for the Mac operating system. It will take a little while, but here it came saying that for this particular file it found the following hash value. So we'll just check the beginning and the end here. Of course you need to check the entire script. I actually maybe think that I can copy this and see if it just finds, let's see. Yeah, so it basically found that the SHA value of the file that I downloaded is the exact same as is on this web page, which is very nice because now I know that nothing has been done to this file. However, you need to be aware of that people can also, if you are affected by a malicious user that has infiltrated your network, they can also manipulate the SHA value, so they can change this before it gets shown to you. So the best approach to ensure you have the right file is to take another device which is on, for example, a mobile network. It could be a mobile. Go into the page and ensure that it's the same SHA value, because then you know that both the file has not been corrupted, but also that nobody is manipulating with the actual web page, because the web page that will be shown on your computer is running through the same routing network as the file. So if a malicious user were to change the file, he could also change the result being displayed on the web page here before it reaches your computer.